All right, let's dive in. Today, we are taking a journey through the world of computing. It's that invisible magic that powers pretty much everything, from the phone in your hand to the cars on the road, all the way to the telescopes mapping the stars. We're going to peel back the layers and really understand the engine that runs our world. I mean, think about it. This technology is so woven into our lives that most of the time we don't even see it. It's just there. But if you strip away all the apps, all the screens, all the complex code, what are we left with? What is computing really at its most fundamental level? That's the big question we're going to tackle.
So, to figure out where computing is headed, we kind of have to get on the same page about what a computer even is. And you know what? The answer is surprisingly simple, almost elegant.
Okay, so here it is. Every single computer, and I mean every single one, from a simple calculator to a massive supercomputer, it just does these four things. First, it takes something in. We call that input. Then, it does something with it, following a set of rules. That's processing. Next, it spits out a result. That's your output. And finally, it has to remember stuff for later. That's storage. That's it. Input, process, output, storage. That four-step dance is the secret sauce behind everything. So now that we have that basic idea down, let's talk about how we got here. How did we get from giant, clunky machines with mechanical gears to the supercomputer that you carry around in your pocket? This isn't just a story about things getting smaller, it's a story of absolutely mind-bending speed. So, way back in the 1800s, you had Charles Babbage dreaming of a steam-powered engine that could calculate things. Fast forward to the 1940s, and we get ENIAC, a literal room-sized electronic brain humming with thousands of hot, fragile vacuum tubes. But then, bam, 1947, the transistor is invented. This was the real game changer. It replaced those huge tubes, making computers smaller, faster, and way more reliable. And that invention led directly to the 1970s and the microprocessor, an entire computer brain, a whole CPU squeezed onto a single tiny chip. That one invention is what put the power of a giant mainframe onto your desk. And that brings us to today, to the absolutely incredible digital world that we're all living in. So let's just take a moment and map out all the different kinds of computing that are buzzing around us right now. Today, we've got this whole spectrum of machines. At the very top, you have supercomputers. They use what's called massive parallelism, which is just a fancy way of saying thousands of processors all working together on one giant problem, like modeling climate change. Then you've got mainframes, which are the super reliable workhorses for things like global banking. Can't have those going down, right? Then there's us, with our personal computers. And finally, you have the ones you never see, embedded systems. These are the tiny, specialized chips running literally everything, from your microwave to the anti-lock brakes in your car. But it's not just about the kind of computer anymore. It's about where the computing actually happens. On one hand, you have cloud computing. This is where massive, remote data centers do all the heavy lifting for us over the internet. It's why your little phone can do such powerful things. On the other hand, you have edge computing. This is the total opposite. It brings the processing power right up close to where the data is being made. Why? Because some things need an instant response. Think of a self-driving car needing to slam on the brakes. You can't have any delay, any latency. And when we talk about the cloud, it really comes in three main flavors. Think of it like pizza. You've got IaaS, Infrastructure as a Service. That's like renting the kitchen. The oven, the flour, the basic ingredients. You build everything yourself. Then there's PaaS, Platform as a Service. That's like getting a pizza kit. The dough is made, the sauce is ready, you just add your toppings and bake it. And then you have SaaS, Software as a Service. That's just ordering the pizza. It shows up hot and ready to eat. It's the finished product, like your web-based email. Now, whether that computer is in a giant data center or sitting in your hand, it all comes down to the processor. And deep inside these chips, there are two competing ideas on how to get work done. First, there's CISC. This is what's in most PCs and servers. Think of it as having a huge vocabulary, a ton of complex, specialized instructions to get a lot done in one go. Then there's RISC. This is the engine inside your smartphone. It uses a much smaller set of super simple, fast instructions. So what's the trade-off? Well, CISC is a powerhouse, but RISC is incredibly energy efficient. And that efficiency is exactly why your phone's battery can last all day. Okay, so that brings us right up to the edge of what's possible today. But the next revolutions in computing, well, they're not just about doing the same things a little bit faster. They're about doing things we once thought were flat out impossible. Let's peek into the future. This is where things start to sound like science fiction, but I promise you, it's real. At the heart of it all is something called a qubit. A regular computer bit is simple, right? It's either a 0 or a 1. It's a light switch, off or on. But a qubit, A qubit, because of a wild property called superposition, can be a 0 and a 1 at the exact same time. It's like the light switch is both on and off simultaneously. And that one weird trick is what gives quantum computers their unbelievable power. So, what can you do with power like that? We're talking about solving problems that are literally unsolvable for any computer that exists today. Imagine perfectly simulating a molecule to invent a new drug, something that would take a normal supercomputer billions of years, or cracking the encryption that protects our entire digital world, or optimizing unbelievably complex systems like global financial markets. It's a whole new category of problem solving. And it doesn't stop with quantum. There's also something called neuromorphic computing. The idea here is, instead of building faster calculators, what if we built chips that are actually structured like a human brain, with things that act like digital neurons and synapses? They're not necessarily faster for everything, but they are incredibly efficient at learning and pattern recognition, which is just perfect for the next wave of artificial intelligence. And if computer chips that act like brains isn't wild enough for you, how about computing with DNA? Yeah, you heard that right. This is about using the building blocks of life itself to store information and perform calculations. The amount of data you could store is just staggering. In theory, a single gram of DNA could hold every bit of data ever created by humanity, all of it. And one last one for you, optical computing. This is the quest to replace electricity with light. So instead of pushing electrons through wires, you'd be sending photons, particles of light, through tiny circuits. The goal? Basically zero heat and processing at, well, the speed of light. It would be another massive leap in power and efficiency. Okay, quantum, neuromorphic, DNA, optical. It's all amazing stuff. But let's bring this all back down to Earth. Why does any of this really matter? Because this abstract technology, this concept of computing, is the engine that drives pretty much every single aspect of our modern lives. Its impact is just woven into the fabric of everything. You see it in the science that's curing diseases and the financial systems that run the global economy. You see it in the incredible special effects in movies and the complex AI that's starting to drive our cars. Honestly, everywhere you look, computing is the tool we are using to solve problems, to create new things, and to connect with each other. When you step back and look at the whole journey, you realize that computing is maybe the ultimate tool humanity has ever built. It's basically an extension of our own minds, one that has evolved from clunky mechanical gears all the way to quantum systems that are helping us understand the universe itself. So, over the last 2 centuries, we've built this incredible, all-purpose, problem-solving engine, and it gets more and more powerful every single day. Which means the final question isn't really about what this engine can do anymore. The real question is, what should it do? What's the next great challenge that we should point it at?